And we're live. Okay. Hello all, hello world. I'm really tired right now, and I've got plans tonight, so this might be a short stream. This is day 151 of studying compilers every day until I land a compiler role. Last time we got colorings pretty close to done actually, which was it was a really good sign, I guess. So we just have like a little bit of cleanup work everywhere to do. Specifically, the two that I'm looking at right now are first like fixing the sizes in coloring, because we kind of messed that up somewhere along the line. And second is doing like interference as a per function thing as opposed to like across the entire program. The thing is, I don't remember which of these I said I was gonna do in the description. So let's see if I can check this somehow. Okay, we're just gonna check the long way. Let's go to YouTube. View channel. Okay, well I didn't specify, which is wonderful. Okay, I guess we can just start writing code then. Yeah. Log. Yeah, okay. So we did all this coloring stuff. I think I will try to figure out the size issue right now. Yeah. So let's, I guess, what do we do with this actually? This is kind of troublesome. This is very troublesome actually. I guess what we could do is, let's look at coloring first. Okay. And then I think we probably want to do something with like tricolor operand, specifically with like size, if I had to guess at least. Something else I was thinking about is maybe just like using an enum for like the colors instead of like, I guess the register is being used for colors, but I guess that would also have the same overlap issues, so maybe I avoid that as well. We don't really care about pre-coloring here, I think. Right? Oh, okay, we get the correct size here, so that's not a concern. Yeah, this is annoying. Let's go lane. Yeah, it's an early stream because I've got stuff to do later today. I've got plans, which means I gotta plan ahead for things. Let's get an arch. I feel like I haven't seen you in a second. How have you been? What am I doing here? This is very annoying. Missed a couple streams? Yeah, I mean, it is what it is. A lot has happened in the past couple of streams, so yeah. Too late? Aw, unlucky. Okay, what do I even do here? Yeah, this is very annoying, actually. Yeah. I guess we don't really map these to sizes as well. I guess if it's virtual, we can kind of just like hard code in to unhard code virtual size. We'll just hard code this for now. So data size, let's make this double word, because we only have 32-bit here, and I'm a lazy chud, so we will do that. Oh, that's very annoying actually. We don't have a good way to like convert these to size. So we might want to redo coloring somehow, ironically. We should probably just give it like register enum values, and then we can just convert those as well, which should probably make things easier. Just working on HUD and making cleanup touches. Ooh, that's a fun spot to be in. Good to see that you've made good progress. Okay, so here let's color this with LAR register num instead. And this might bork a lot of code, but evidently it is borking a lot of code. This also means we can just take color here, actually. And then we can make this like reg or something. Do you mostly code C++ when developing compiler? How often do you use TableGen? I have not looked at TableGen yet, to be honest. I'm not using like LLVM is the big thing here, so it seems a little awkward at least. Oh wait, no, we still need physical reg. It just occurred to me. Just instead of this, we use color. Like that. Enums are underrated? Yeah, I think like, I don't know. A lot of code is also like written at a different time as well. So I think that also might affect it to some degree. What's good, Max? Good to see you. Okay, so let's do register, or we want to get register at LAR to sized. Let's give it color and then size. We'll make a mess out of this. Like that. Do that. Let's do base color. Let's do index color. Otherwise, it's LAR. This is very awkward, actually. I guess we could do virtual as like a default, maybe. So if base exists, actually let's just do it differently. We don't care about the color here, so we can just, let's keep that. We can do layer to size. Let's just wrap the hell out of this. Let's just get register at that. We're just gonna make a mess. It's fine. Yeah, so we're just gonna zoop that there. Instead of base, we want index. Oh, we need the size as well. So we have color, and then we need size, I guess. What is wrong here? Oh, I put it in the wrong. Right, like that? Comma. Okay, first try. So we just move that, and we're good to go. Okay. This is a mess. I'm enjoying this a lot. Hopefully y'all are enjoying this as much as I am. What else do I need to do here? We need to fix this stuff. Instead of this, we need register num. Yeah, okay, we can do that. I'm not sure why this is wrong. This is a register num. Oh, why is this a putter? There we go. Do that as well. We need to make that layer register num as well. Yeah, a lot of refactoring, but this is life, I guess. Let's just make this virtual register. Oh wait, wait, no, we want register num virtual. That's what it was. So I guess that is like more clean than null, to be honest. So I guess I can't really complain that much. What do we do here though? I guess we just do LAR 2 sized. Let's get the color of reg. So we get the number. Let's make this data size quad word. We'll just do that to standardize it. And then here, I guess we could just do new color, I guess. We can just yoink that. And then this will simplify things a little bit. Okay. And just do that as well. Actually, since none of these are void anymore, we can get rid of this like awkward thing, I think. So we could just do, instead of that whole mess, we can just replace this with lar2 string, and we can just give it color, like that. Which condenses our code a decent amount. Let's see if this builds. This color scheme's also getting old already. Let's make it, I don't know. How's the job market for compiler rule? It's alright. It's about the same as like any other, I guess, sort of job market nowadays in like life, I guess. These look like the correct sizes now. What is happening? So we're using L, that looks good. So, evidently we've done something wrong here. I think something is very obviously wrong there. I will have to do something about that in a second. Yeah, these are all the double word size registers now, which is good. I think this actually puts us like pretty close to generating like real code. We will definitely find bugs later, but yeah. Well, like what can you do? Let's hit it with O1. Does this do what we think it would? I guess it does. Eventually we could probably do some like label removal stuff, but that's like a future concern for me. Yeah, okay, so we probably need to change this like MOVQ generation. So let's source real quick. Commit. The funny thing is I feel like none of this has messed with our regalloc code at all, because this is all kind of just like compartmentalized into like its own, like the coloring stuff is compartmentalized, which is neat, I guess. So that kept everything like pretty easy to maintain actually, which is probably the first time I'm saying that about this project, because maintenance of this thing has just been a pain this whole time. I've not enjoyed maintaining this just because of the general bad decisions I've made around designing things historically, which is like, I don't blame myself for, but it's like, you know, you get what I mean. Okay, so what do you do here? Fix coloring for sized registers. What else do we want to do here? We were going to fix generation for return. Okay, so we do EAX here. What is size? This should not be quad word. Yeah, we're just gonna be lazy with this. We can't regenerate tests yet. Oh yeah, that fails tests for aforementioned reasons. Okay, this will just make a mess, which is life. Yippee, it's correct now, I think. Okay, let's what do we do now? Let's commit this. Double word in return instruction instead of Q. Okay. What else do we need to do? Yeah, okay, I guess I don't know. I don't really know what I want to do from here. I guess we're like done with coloring, right? So I guess we're definitely done committing sizes, I think. Just to give this a try, let's just give it a giant test. And by giant I mean like, let's give it call chain. Okay. What happens if we give it -00? Okay, so it needs to spill, and we might not be able to spill yet. I should probably do coalescing as well, actually, but all of that requires spilling, so I'll do spilling later. For now, O1 output. What is happening here? Oh, I see. We're saving the registers. Yeah, I really need to figure out coalescing sooner than later, because this is getting quite untenable, actually. Like this register saving thing is not very pretty. I do not like this. I do not like this very much. Like we could skip this MOV with like coalescing, for instance. Anyways, we'll worry about coalescing later. For now, one small thing I wanted to mess around with is wait, there's something else I was thinking about. Oh wait, I was thinking if there was a way we could like maybe make like function params, or like we could do something with function params to like reuse those registers, but I don't know. That's something I need to like think a little bit more about, just like later on at a different time. Sorry, let me just reply to someone real quick. Yeah, okay. Had to answer a question real quick. Okay. So I guess the other thing we could do in today's stream before I promptly disappear is getting this like interference thing fixed up. Because right now we just like make one interference graph for the entire function, but realistically, if we're doing like, we're already doing like liveness per function, right? So we should probably do interference similarly. We could do that, Or something else I was thinking about is we could maybe just like, I guess we don't even need to like be very insane about this. We can reuse a lot of our code. Something else I was thinking about is if we should be storing our like liveness stuff the way that we do. Yeah, because we just like store all of there's like one layer of vector here that we could probably skip if we just like recompute differently. So I'm gonna try to get rid of that, and then we can then make our regalloc just run per function, which is also very nice. Maybe we just change it here and then we like wishlist it over. Let me do a little replying. Okay. So let's add another loop in here. So just for auto f in, let's just get each function. What's good, John? Haven't seen you in a second. It's good to see you here. Okay, we can do that. Maybe I could like, maybe I'll just make helpers at like each for loop level, and that might make things less ugly. But I feel like this is kind of necessary. Yeah, so we just do regalloc per thing. Can you make all of those visit, call into an array, and loop over it? What do you mean by that? Oh, like this slush pile? I see. I mean, the thing is, like, the whole point of it is to do like double dynamic dispatch, so it kind of gets awkward to like do anything else with. The moral of the story is I should just not use C++. I should just use OCaml. OCaml is like the solution to everything. Unless I want to like write real code, then like Rust is the solution to everything. But like, just like anything with like good pattern matching, like please, just give me something that can like do pattern matching, and I will be happy. But yeah, like I've been using OCaml in our like PL pragmatics class, and it's been fun. It's definitely felt nice actually having like a language that lets me write a parser that doesn't make me want to like gouge my eyeballs out. I forgot who it was, but someone mentioned in chat yesterday that like there was a C++ pattern matching proposal, and I looked at it and I hated how it looked. So I don't particularly want to do that. So not very ideal, at least. Yeah, okay. So let's change liveness real quick, the way that we do that. So let's liveness. Let's change the header first. Let's get rid of one array level, or let's get rid of the one vector level, so this is less messy. And then this, I think we just use this alias everywhere. Can't you while, yeah, oh yeah, I could do that. I think, yeah. I forgot about that. Or it was for, it was like that, right? I don't know. I could do that, but like, I feel like while true is more readable, so I will stick to while true. But I like accidentally found out about the for double semicolon, and I lost my shit that day. It was so funny. I was looking at just like the insane C programs, or just like insane C syntax things. It's like the like really famous thing where like if you have like indexing, it's like, let me just stick this up here. So like if we make like we can just do that. Or wait. How do I make an array? Okay. So if we make like an array, well, so like usually when you like index into it, you do like temp like 1, right? For instance. But the way like the bracket operator works, like this is like a pretty famous example. You've probably like seen this somewhere, but like you can do 1 bracket temp as well, which is like really cursed. And it's like, what are we doing here? Like this is completely valid code, and this does the same thing just because of the way the bracket operator works. But like, oh my god. Like, what are we doing? Yeah. Let's go Lemonbot. Good to see you. Can you provide a roadmap and resources for beginners, please? For what specifically? Because the answer will vary a lot if you're talking about like how to code or like how to get into compilers. C++ is C with an increment operator. True, that should go on a shirt, actually. Yeah, I'll let you make the shirt. I'll let you take credit for that one. That one's pretty good. Have you read Crafting Interpreters at all? I haven't like formally read it, but I've looked through it, and I've recommended it to people at least. That will actually be my first answer to first answer to like compilers roadmap. I think you should start with Crafting Interpreters. It's like a pretty good introduction to just like programming languages. It's like this neat little web book. You walk through it, you write like an interpreter. It helps you just like think about like generally how programming languages are implemented. And then from here, the next recommendation I have is writing a C compiler by Nora Sandler. This is a pretty nice book. This is not the book. This is the book. There we go. Yeah, I think that's like a pretty good place to get started. And then from there, there's like a lot of different places you can go. I'm kind of at like this sort of point. I'm not like following this book, but I'm approximately doing what this book does, at least. So yeah, that's like the very short version. Can you put those recs in the description? That's a good call. Maybe I was like thinking about getting like a YouTube bot to do that for me, but so it's like a command, but I don't know. It feels disingenuous for me to like give like very formal recommendations, at least, because I'm not really where someone starting out would want to be. I feel like I am still someone that is like technically starting up, so starting out. So like it feels like very like I feel like I can't really give like a very strong recommendation to anything because I'm not at that point yet, at least. Both where I can evaluate like what is like very, very good recommendation wise, and in terms of like just like credibility, right? So maybe in the future, maybe once I'm employed, and maybe once I've worked through the books, but until then I don't think I will do that. Maybe I'll figure out YouTube like Nightbot or something. I don't know. Okay, what was I doing? I was cleaning up this stuff. So we need to clean up liveness real quick. By real quick, I mean really slowly, actually. I think all of this is sufficient for that. Yeah, we can keep all of these. We can just get rid of a loop somewhere here, I think. Oh wait, I see. Something I forgot real quick. In regalloc, liveness, we should give it F. And then interference, we should give it F. And try coalesce, we should give it F. And then try color, we should give it F. All of these we should give it F, pretty much. I think that's all we need here. Can you write some OCaml for us? Later problem. Okay, let's start here. Let's replace this. Function. Do that. There's some places we might need to pass in like the operand manager, but that's fine. We'll just grab it in one place. This is in color. Is this all good? That's all good. We're gonna need to update the interface later. Let's look at regalloc. Okay, the stuff at the bottom is good now. What is wrong with this now? Tricolor is not good? What do you mean? What do you mean it's not good? I'm looking in the wrong place. Whoops. Okay, so coloring header. So we have function, ref. What is this? This is a unique pointer, I see. Okay, let's just stick f.get everywhere, actually. Yeah, let's... but then these are putters. Oh, that's really annoying. Okay, 1 second. Right, is this good? This is really annoying. Okay, let's just give it putter. And all of our problems will disappear once we give it putters. Interesting, okay. Apologies if like some of this is covered by my camera. Feel free to yell at me if that happens, I guess. Okay, these visitors are fine. I think all of this is fine from here. Yeah, okay. That's all the coloring stuff in the header. We'll fix the body in a second. Better to get recommendations from beginners. I disagree. I think the biggest problem with that is that like, you don't really know what you don't know. So like for instance, I haven't like formally worked through crafting interpreters, so I don't really think my recommendation is like very meaningful in that regard. And there also might be like some other resource that someone more tenured might know, but I don't, for instance. Okay, let's fix the liveness header real quick. Function putter F. Yeah, we'll do that, and then we'll fix interference real quick. Star F. And then coalesce, we have not stuck anything in here yet, so let's do function star F. Okay, let's just work through these real quick. This is like the easiest one to fix because, well, we haven't done anything with it, so we can just leave that as is. Let's work through coloring last. Interference is like the next level. So yeah, that's the function level. Okay, we don't need one more level of this. Yeah, so we don't need this outer layer of the loop. Like that. Yeah, so we can do that. Instead of this, we can get rid of this bracket level operator, or access, I guess. We can do that. Okay. Yeah, this seems like everything we need to fix. Right? Oh, wait, no, we need to change this, obviously. Function star F. Okay, we need the operand manager now. So we need there operand manager star om. But that's fine because we can just pass that in. But I also need to update this. Oh, we can paste that there. Recommendations is fine if it's well known, but mention if you haven't had the personal experience to vet it. I think that makes sense. Yeah, that sounds pretty fair. Maybe I guess that might be the stance I take in the future then. Like that seems quite reasonable. Also, this means I need to update this real quick. Let's get like operand manager real quick. So this is lar get om. What type is this? Operand manager star. So this is dot. So that is a putter. So we can just feed this in here as well. And life is good. Something I dislike about it is she doesn't go in as deeply as to how to make the things. I guess that makes sense. I guess like I feel like that's just kind of like a pedagogical choice. I personally am like a fan of that at least. Like, it might, like there are times where like it definitely feels a little bit dizzying, but I also feel like, even just like here for instance as an example, this whole like regalloc thing, I think a lot of this is like me just like taking the raw theory and just like figuring out what the applied form of it looks like. And I think that is like the most valuable part of the learning, because it's not only like, it doesn't just require like an understanding of like what's happening, but also like enough understanding to also like literally contextualize it. So I think that's like that's like my personal stance. I guess, yeah. Again, I haven't fully gone through it properly, so what I can say is like relatively limited. Yeah. That's like my whole spiel. Okay, I think that's everything in interference fixed, I think. We'll find out very quickly when something explodes, so this is fine. Liveness is next. Everything is function, right? 1, 2. Oh, this is spill. I'm looking in the wrong place. So this should be lar function star f. Program. Oh, wait, this can cause some problems actually. It just occurred to me. Let's make, what the hell? Let's do that. This also means I need to change the visitors, actually. Is that the only visitor I need to change? Oh, neat. Okay, fair enough. That's quite nice. I don't think I need to do much else there. I think we compute that every time anyway. It looks like we do, so I think that's fine. The print should be easy to fix. People may be expecting the author writing C compiler to be like crafting interpreters. I guess that's fair, yeah. I think that's like, I feel like it's more representative of like the actual like theory experience of compiler work. Because like, you look at like LLVM's docs. I lied. You don't look at LLVM's docs because they don't really exist. So it's like, you do have to just like kind of figure a lot of things out on your own. And I think it's probably the most representative experience you can get, in my opinion. What the hell am I doing here? Okay, let's get rid of that. Okay, we don't need this new line here, I think. Let's steal that. Let's yoink that. We can just do that. I think that's fine. What the hell am I doing with like index? Oh, I'm indexing across all of these at once. I see. Okay, this makes sense now. Important to be able to take ideas and abstract/implement them. Yeah, exactly. I think like I really do think that is where most of the learning comes from. What language are you using? C++. But it's like really sloppy C++. So like if you're trying to emulate code, I would not suggest emulating my style. Okay, this is the function name. This is fine. This stuff is fine, I think, from here. Okay, we need to do something about this. So P doesn't exist anymore. We can get rid of that. Let's get rid of that as well. What's the best way to learn how to code? Just like pick a tutorial online, any tutorial, and just follow it. And then from there, use what you learned from the tutorial to make something is the second step. We have to give it the OM again? Okay. 1 second. Let's fix this up. So you get a function, and then operand manager star OM. Let's change that to OM. Okay, before I forget, let's update this to take OM as well. Do that. We need to update that as well. Okay. Maybe I should like not do this every time. So let's actually like auto f putter equals f get, I guess, or dot get. Let's actually just find and replace. Let's replace it with f putter like that. And then let's patch this real quick. There we go. Yeah, I think also like knowing what you want to do with programming will help like pick a better resource, but at least like generally speaking, I think the process is still about the same. Okay, what else do I need to change here? What the hell am I doing? We don't need this anymore. So that breaks a lot of other things. Or all of these actually, but this is fine. Let's actually rename some things real quick. What are these F things? Oh, I see. Let's just make these gen. Let's make this kill. And then let's make this in, let's make this out. Okay, and then this becomes nonsense, which is good. And then that fixes itself. Out of line, I need to change this. Function star. We don't need that anymore. We can just keep that as is. I think all of this stuff is formatted now as well. Yippee, okay. Where is the other stuff I changed? Ah, there it is. Do you normally use a debugger? I forgot to answer that, that's my bad. Sometimes I use it, sometimes I don't. It depends on what I'm doing. If I'm like trying to just like figure out what's happening somewhere, or like, I guess what a certain value is somewhere, I probably should use the debugger, but realistically I feel like I should use it more, but for now I just like print stuff out. If I'm like trying to figure out what is wrong like execution flow wise, that's usually when I get into the debugger. I probably should get more practice with a debugger. That actually reminds me, I have this little I have this little stream idea cooked up for the future, but if y'all remember like from your like college courses, I'm not sure how many of y'all have like done this in your intro to systems class, but like a lot of schools use like there's like this one systems textbook everyone uses, and in it there was a very famous lab by the name of Bomb Lab. It's been a while since I've done that. It taught me a lot about how to use a debugger. I've since then gotten worse at using a debugger. And one of my friends is also in a similar situation, and he also happens to stream. A certain Aiden Lee. So we will probably stream ourselves like trying Bomb Lab again from scratch, just on like the publicly available binary. So as not to like ruin like academic integrity shenanigans. Yeah, I feel like that'll be a fun stream. Stay tuned for like when that's gonna be, at least. I'll probably like announce that sometime eventually. Does compiler rule mean you get a job as a dev in that field? Yes. Sometimes when I code, I always feel like there is a better solution. When I ask AI, I feel very disappointed when it implements a better solution. I feel like that's a good outcome, actually. Because like then you're like learning something new, and then you can also like think about whether it's better, and B, if it is better, why it's better. I'm like, as long as you're like always learning, I don't really think there's anything bad necessarily. It's a lot easier to like take code that exists and like make it better than it is to like generate something from scratch. So AI will naturally not be that bad at that, in my opinion. Okay, I think I've cleaned up liveness sufficiently. Just to check, program, no program, yippee. So that's all of liveness done. Yeah, okay. So next is interference, I think. Program, no program here. Program. Okay, we did interference already, never mind. So coloring is the last thing, for sure, because this I definitely said was last. We fixed all the headers. So let's replace LAR program ref LAR with LAR function star F. 3 substitutions, okay. Okay, this makes a mess. This definitely makes a mess. We can just do that. Here we need to just pass in the operand manager though. So we need to do like where operand manager star OM. This is color registers. So we give it fputter, coloring, and OM. We'll fix that in a second. Actually, let's fix it now. I'm gonna forget. There's so many moving parts. It's hard to keep track of everything. Here we need LAR operand manager star OM. Maybe doing that was a mistake because now we're like using an operand manager, and it's made a bit of a mess now. I have to pass it around everywhere. Are you building your own compiler? Yes. Completely from scratch, barring like a parser generator, because I don't care about parsing enough. Okay, we can give it F there. We need to give it OM again. Let's give it OM. We don't need that layer. That cleans things up a little bit. We need to update this. I feel like everything just needs it now. OM doesn't exist because we don't give it this yet. Nice. Okay, wonderful. Great. Maybe I'm moving too fast here. Print coloring is fine. That's like straightforward. Color registers should be fine now. This is updated. Tricolor is where we are. So we need to pass in the operand manager here. What's wrong with this? Manger. What is this, French? Okay. And then we also need to update this here. Let's do that. Pre-coloring has operand managers, that's good. Everything else here does not change one bit. External lexer or parser? I guess both. Let me just like show you. But like, if you've heard of like Yak or like Bison, it's kind of like the same thing, but just in like C++. So like, in here in my parser file, I use this thing called Pectool, which is like parser expression template, like parsing expression grammar, so PEG, and like template library. So if you like scroll down here, there's like this whole mess where I define a bunch of tokens, and like it's really ugly. Don't stare at it for too long, or else you might get an aneurysm. And then like this is where I handle like compound expressions. And then like here's like a couple. This is like where all my instructions live. I'm going through this a little quickly because all my code's on GitHub. And then like this is like more program unit level things. And then this like actually takes the parsing output and like turns it into an AST at least. Yeah, and it's just like a big slush pile, and like that's kind of the average parser experience, I guess. Trying to make a parser for a basic language, confusing as balls. What's been your biggest challenge? Parsing is, I feel like parser generators are just like really annoying to like read output, but biggest challenge wise just across everything, I think the optimizer is probably I think the optimizer, at least setting up the optimizer initially was hard, just because like SSA construction and destruction is kind of difficult. Just like look that up if you want like a better explanation. The real hardest part has definitely been the backend, just because there have been so many moving parts and not a lot of infrastructure to really clean it up. And it's one of those instances where like your implementation cleanliness really depends on like getting the data structures correct, which is why I'm like fudging around with the data structures so much right now, just because like I did not design these correctly on the first try. So I do just need to deal with that. Okay, let's see if this works. If this has a linker issue, I did something wrong. Ah, crap. Okay. Compute liveness LAR. Where does this live? In the test runner, that's where it is. God damn it. Okay. Let's go here real quick. This is really annoying, actually. Let's just comment this out for now, and we'll just be lazy. We'll just worry about that later. What do you think about giving AI writing a C compiler and having explained how things would work? I think that might work. Like that might just be something you have to try, but like your mileage may vary at the end of the day. How often do you look back on your code and be like, wow, that was a terrible implementation? Very, very frequently. I think if I had a nickel for every time that happened, I would probably be able to turn off ads on my YouTube videos. Not that that means a lot, but it's a non-negligible amount, at least. Okay, so let's see what this vomits out now. That's not good. Why is that infiniting? Let's go Jatsu. Good to see you. To do? Yeah, I'll do that. I'll worry about that eventually when I decide tests are important. Back in school, but no programming classes. Aw, that's rough. Why is this infiniting? This doesn't make sense. Oh, it's call chain. That's the really long one. Okay, like we can give it square real quick. That works. Wait, what? Wait, why didn't what? Huh? Okay, let's throw this in Valgrind. I've been getting into ASM x86 64 Intel. Want to convert to direct assembly. I see. Yeah, so I guess I could kind of. It's been a second since I've given this spiel, so I guess it makes sense. So this is like the general like compiler structuring thing. So usually when you have a compiler, or usually like, how did I start this again? It's been a second. Okay, so we have like, let's say we have like some source language. So we have like C, and then we have like x86, 64. And ideally we want to just like, we could be like happy just like converting this. But then at some point like we decide like there are more languages and like we want to add more assemblies. So like, let's say we had like some sort of like ARM here, and let's add like just normal x86. And let's be insane. Let's say some chud wants us to like write Python actually as like a backend even. I don't know. And then like we also want to like support more source languages because, well, who doesn't like more source languages? So we have like C, we have like C++. C++ to Python would be insane. Let's say like Rust as well. Just as some examples. So if you were to write like one compiler from each source language to each, I guess, compiled language, I guess backend target language. So we have like source and then like target, I guess. So we have M of these, we have N of those. This drawing is very scuffed, but so we have M of these, N of those. We'd have to write M times N different compilers to get each possible combination of these. I'm not going to draw the lines, but yeah. So the way that compiler engineers have decided to avoid this problem is to make this like this little box in the middle, and this is like another intermediate language. Generically, we call it like an IR, so like an intermediate representation. The idea is then you can just like write 3 different half compilers here, so M different half compilers, and then like N different back half compilers. So that lets us write M plus N instead of M times N. So then we can kind of like treat these as like different phases, and this is where like front end, middle, and back end comes from. So we can split it like this. All of the stuff here is considered the front end. The stuff in the middle, because it turns out we can use this as like a generic optimization we can, I guess, generalize a lot of optimizations because they all compile down to the same IR. So we can use this as a middle end. If I can write properly. And then this part that handles codegen, we call the backend. Without M by N, we'd still have an IR. That's fair, yeah. Like, I guess that's fair, but this is like the, I guess, generic IR. Because like we still want like a memory representation to like be sane with things. Yeah, exactly. Because if we're just going straight without an IR, we will probably like want to launch ourselves off a cliff. Yeah, so the front end just like handles this like direct conversion down to an IR. So like desugaring things. So like we get to, I guess we'll just write it as like desugaring generically. Let's just use red. So like things like turning like loops and loops and like if statements into just like go-tos, I guess. Turning those like compound operations like we have like 1 plus 2 plus 3 plus 4. Those are like with variables, like I guess A plus B plus C. Handling that sort of stuff, making it somewhat more manageable, just like simplifying the code in that regard, just like the, I guess, number of different operations we can do. The IR is where all of the big optimization happens. So like we turn like 1 plus 1, we turn that into just 2, for instance. There are points where we can just like replace an entire function with just like the output of it, depending on like how the function is written. There's a lot of like crazy stuff that happens here. The part that I guess we care about here is the backend, and a lot of stuff happens here. So there's like instruction selection, where we turn the IR into something more close to the relevant assembly. Because they don't necessarily map one-to-one onto each other, we have to do some like funky stuff. Then there's like regalloc. That's like kind of the hell I'm in right now. That is like turning variables into registers, because we can have like infinite variables and we might not have infinite registers, which is also a problem. So there's like some shenanigans there. And then like cogen, which is, well, taking the output of that and turning it into like actual assembly. Aside from that, there's some like other things here. Like you can do like small like spot optimizations, I guess, which is known as like people optimization. And then there's like, you can like reorder instructions for like scheduling efficiency. So I guess scheduling, I guess. I explained this very poorly, but yeah, this is like kind of the very fast version of this. Yeah. How do you handle IR to assembly? It's just this little pile here. That is the very TLDR version of the very long-winded talk, I guess. Compilers course this semester, super excited. Ooh. I might be biased, but I quite enjoy compilers classes. How's the work going? It is rough. It is very rough. So much slush to sort through. Lots of refactoring to be done, because I'm bad at designing things correctly, but we're getting there in the end. What is going wrong here? Coloring 79. Coloring at reg. Should we put live ranges into registers more than entire variables? Yeah, I guess that makes sense. I don't remember what I do here, actually. I guess like we've just came out of SSA, so it's like close to live ranges, but like the simplified version is, I guess, variables. Yeah, maybe I shouldn't have done SSA destruction before. Oh, whatever. It's life. Okay, so 79. What is going wrong here? Coloring at. Are you doing any intern? I have an internship for this upcoming summer. It's at a local trading firm. I get to mess around with GCC for 3 months pretty much. So that should be a good time. But I'm not counting that towards like the series, because it's not full time yet. Okay, what is going wrong here though? So it's an MOV. What is going wrong here actually? Did we just like not color something by accident? Can you get me an intern gig? I don't know how to draw cubes with OpenGL. That's huge actually. I might not be in the place to do that, unfortunately, but I imagine there are also plenty of other people that are in positions where they can do that. Okay, what do I do with this? What is wrong here? What register are we not mapping properly? Go up. Let's just rebuild first before. We'll ignore that for a second. So it's an at issue. This doesn't make sense. I feel like this shouldn't be possible at least. What's an MOV? At line 109, so here. So we're looking at 01 call chain. Let's look here. MOV, uh-oh. Okay, we might be here for a while. Where could this be borked? Where haven't we colored something? That doesn't make sense. I'm quite confused. I'm quite confused. Let's just print reg. Or string. First try. All right, let's see what this vomits out now. We'll figure out where it's bricking. What? Terry Davis has been my inspiration. Ooh. Okay, yeah, that is a good place to, I guess, get inspiration. Yeah, let me know if there's anything else I can attempt to explain at least. Have you contributed to open source? I was gonna, and then I kind of forgot about it because it turns out this project takes up a lot of time. So, whoops. Risk SIMD is in fact rough. I do not envy you in that position. So where is this breaking? I don't understand this. What resources do you recommend, like books, websites, and playlists? So currently the two big recommendations I give are... My mic is getting in the way. This is irritating. Actually, yeah, that is a good question. Books / resources for what, at least? Let's just count pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, this doesn't make sense. So this is like 2 pairs. Down here is like 5. I forgot what I counted. Let's just read through this again. 8, 9, 10. 15, 17, 22, 24, 26. 26 and it's a 0. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's here. So here is where it's struggling. Why is this not mapped? This does not make sense. Yeah, Lane's recommendations are my recommendations here. I think those are good. Those are pretty good starts at least. And from there you can kind of learn whatever, to be honest. Okay, so why is this problem? Why have problem? Is my liveness wrong now? Why is this out of range? Wait, why is this out of range actually? So you have coloring. So this was committing the coloring. Engineering and compiler. I've also heard good things about that. Just from like various different people. That's another one people like. I personally didn't really like it a lot, but yeah. Alex Lykin's compiler course. Ooh. I actually haven't heard of that. So like that's another example where someone more tenured can probably give a better recommendation than me. Writing interpreter in Go, then writing compiler in Go. Yeah, those I've heard of people liking those as well. Yeah, engineering compiler just did not, I don't know, I just didn't really like the way that the specific section I read was explained, at least. That could just be like a very unlucky draw, but like it is what it is. Okay, which part am I looking at? So the coloring. I guess we should print the coloring real quick. Let's see with that. That will vomit out failures, that's fine. Let's add another new line here. Maybe I should just do make build instead of make, huh? So is 0 just missing here? 0 is just missing here. Why is 0 just missing here? That doesn't make sense. 0 should not be missing here. Okay, we've got a puzzle. We got a puzzle to solve. Let's look at liveness. Alright, let's go to regalloc. Let's print liveness. Oh, what does this take again? What does my own function take? F. Oh, not F. F putter. That's what I called it. There we go. Wait. Okay, we're not actually gonna. Okay, this is fine. This is fine. This is fine. Let's just zoop. Okay. Debugger? Nah. I need to actually figure out what's happening. What the hell? What prerequisites do you need before these books? You probably need to like have strong like graph fundamentals. I think C is like probably fine to learn. But you don't really need to know C, I feel like. It'll definitely help a lot at least. Graph fundamentals are the big thing, I think. And then just like some basic understanding of like some basic like systems knowledge, I guess. Okay, let's figure out what's happening here. Okay, so 0 just disappears. That's not good. That's very not good. 0 should not be disappearing. Our in and out are definitely wrong throughout all of this, I feel like. Yeah, something has gone very wrong with my liveness, I feel like. If I had to guess. But I guess that's kind of something that like makes sense because we haven't really debugged it. So like I think this is kind of expected. I think this should be fine, at least. Okay, this print format is like really bugging me. I think I messed something up somewhere. Where's... Oh, I see what's wrong with my print now. We don't need this new line here, I think. Right? What was I doing? Oh, wait, my two-string visitor is being yucky. Well, whatever. I'll fix that later. Maybe I'll fix it now, actually. This is definitely bugging me. I'll deal with it later. Ask GPT? No. Yeah, we'll deal with this later. Let's just add that to the big to-do pile. Let's get rid of that. This is what we're working on. What am I looking for? Ask Gemini? No. Fix printing. And then... I guess fix liveness. Ask Opus? No. Ask me? Yeah, that sounds much better. What do you think is going wrong here? I feel like I'm not propagating things correctly in my liveness. Ask GPT and tell you. That's huge. That's wonderful. I mean, like, fair enough. Okay. There might have been something that I like borked when I messed up. I can put data flow code to the side. Oh, I see. Yeah. Let's just Minus. Oh, look, a normal color scheme for once. Is it this? Alright, let me... Wait. I think this is all fine still. Let me just scroll up at the top. Just saw this video on my feed. Welcome. I remember compiling the subject in my bachelor's and really liked it. My career deviated to backend APIs though. It happens. But yeah, thanks for stopping by. Okay, I feel like this loop is innocuous at least. So let's just scroll down a little. Let's look up, sorry. Let's look up the big Wikipedia page. Let me get dark reader on this. Let's just stick this in the middle here. I pray this is remotely readable still. Let's do that. Too many English words, not just letters. Yeah, it's a little bit too far in Funland. But yeah, I appreciate the support lots. Let's move a little bit over. There we go. Gen is used before assignment. Kill is assigned value. Use Linux, Valorant, unfortunately, which means I might not be on Linux for a hot second. Dual boot, too lazy. WSL does what I needed to. I can't really complain. How do you even apply this math to what you're doing? It's like this, but just as like a fixed point algorithm, I guess. We just do this until we get no changes, I guess. Maybe there's something that I messed up with, like renaming somewhere. So we have in, so I guess live in. So we start with the gen set at I. So for each in out, so this corresponds with that, I guess. So if kill does not contain it, then we insert it. That makes sense. If you need real literature, yeah, that would work. But this should be fine. This is just like the least ugly version of this I could find somewhere, at least. Oh, maybe my final out is wrong. There's a chance that's what it is. I don't know. I'll worry about that in a second. Okay, and then out. So for each successor, so successor is P. Okay, so we just get the in of that. Well, that doesn't help. So this looks fine at a glance as a fixed point. So that should be fine. Maybe it is like the last? No, that doesn't matter. Maybe there's like something really awkward that I'm forgetting in the MOV. Maybe my gen is wrong then, right? So where's the 0 coming from at least? So 0's in there. I guess it won't be an in and out, huh? Maybe I do just need to walk through this to color then. Maybe that's what I'm forgetting. Wait, no, we read from 0, right? We accumulate from 0, right? We definitely use 0 somewhere. Right? I hope we use 0 somewhere. Wait, we might actually not use 0. Wait, let's look at the source. Call chain. Yeah, so we don't use it anywhere. That might explain things actually. That makes a lot of sense, huh? Okay, slight problem. Slight problem has been resolved. Okay, that does explain a lot of things. So I guess that shouldn't matter. So what do we do with this? How do we handle this at least? Because right now I just like assign everything. Grr. So just to confirm this, if I comment this out, let's close out of this real quick. Okay, that works now. That very much works now. Okay, well, I guess we found a bug that we had. Very inadvertently, but sure. Okay. What do I do with this? Actually, what do I do with this? The way my IR is designed, we kind of have to call it. We could probably... that's really annoying. Okay, I guess we might just need to add more things in interference then. Liveness is probably fine. At least just by the book. So, okay, let's commit this all real quick. Oh god. Let's get rid of that real quick. Function-wise, regalloc passes, I guess. Okay. Now we have fun. Now we have fun. We need to fix this up. So the problem is the variable's not used anywhere. But I don't think I can delete the function, at least without like more analyses. Or I can't like safely delete the function without doing more middle end stuff. I should add attributes. I really should add attributes. Okay. What got you into compilers or work on a compiler team? Ooh, yeah, so 2 years ago I took a compilers class on a dare, because like one of my friends was like, I'll take it if you take it. Because like the class is like notorious for being like 20 hours of work a week. And then I promptly got my ass handed to me for like the first 3 weeks. And then after I slowed down and started actually like paying attention in class, I was like, this stuff's low-key kind of cool. So after the class, I like reached out to the professor. Yeah, I reached out to the prof and I started doing like research with him. So here I am now. Call is fine, only the move into dev null. I think what's happening is, since the output is not being used anywhere, since the output's not being used anywhere, we're not coloring it, since it's not being used anywhere, it doesn't show up in and out, which means we don't stick it in our interference graph, which means it doesn't get colored, which means when we try to color it, or when we try to commit its color, it doesn't exist there, which is a problem. Recommend meta for compilers, less the compiler jobs. Yeah. I know like my the PhD candidate that's like mentoring me right now. He interned at Meta this past summer with like KlingR, so I draw a lot of inspiration from him at least. So what is the best way to do this? I guess if it doesn't exist, we could kind of just like yeah, where do we stick this? Where do we stick this output? I guess we should get rid of the move somehow, but how do we do that? Yeah, I don't know. I'll need to figure out what to do with that. In the meantime, I guess we just throw it in interference somehow. I don't know how we want to do this. We could just add a register and call it a day, I feel like. We could just iterate across everything and just like do this really sloppily. Wouldn't it make more sense to actually get the compiler working and then add optimizations? Yes, that's why I've like taken a step back from doing more middle and stuff. And right now I'm like literally just like, I'm doing all of the work to literally just get it to generate code at all. But like previously I like spent a lot of time on like just the middle end because, well, that was what I was interested in at least. What do you do on a compiler job? I imagine a lot of just like maintenance work. If it's working on like one of the large open source projects. If not, I imagine it's just like the usual software dev stuff, just like on a compiler instead of on some poor Java web app at least. Okay, I need to figure out what to do with this actually. So we have gen and out. I guess what we could do is we could just like loop through kill and then just like we could just insert it into the map at least somehow. Okay, let's do something really gross here. Here's what we're gonna do. auto kill equals L1, I think. I think that's which one it was. So we're just gonna okay, y'all are gonna absolutely hate me for this. Okay. So we're just gonna auto. So this. So the vector of. I see. So a vector of sets. So for each, I guess, kill I in kill. Please, y'all are actually gonna hate me for this. So I guess, and then, so for each, reg in kill I, we're gonna. I can't think about this. Can't think about this too hard, or else I'm gonna like explode. Here's what we're gonna do. Oh, it lives in interference builder. Damn it. Okay. Here's. Okay. Let's. Okay, we're gonna add something to this. In interference builder, we're gonna do like bool or void add reg. We'll just do this, and this is gonna be like the most garbage slop that we have seen here, I feel like. Oh, we should probably also do this with like gen as well, huh? Okay, we are kind of just like doing the thing that I said I was scared of doing. I think out is already accounted for, but we'll just do this first. So we will IB add reg. Let's give it reg. I hate how this looks, but we can afford to make this faster later. Okay, let's implement add reg real quick. This is going to be a very stupid looking function. Let's paste that there. So we're gonna do interference, bracket operator reg. That's it. That's all we're gonna do. So just to check real quick, if we do this right now, we get an out of range. If we write this, if we make again, ignore the test failures that will happen in 2 seconds. 3 seconds. So we're gonna ignore that. This works now, okay. What have I done? Anyways. Let me catch up on chat real quick. I am not familiar with Europe, but I imagine like a lot of the roles I see, I feel like are in places that aren't the US at least, so you should be able to find something at least. What code editor are you using? I'm using NeoVim. Have you considered pure functional programming? Yeah, that's something I've like thought about. I think in an ideal world, I either use like functional or I just like suck it up and use Rust. Not that I would complain about using Rust, but the main reason I picked C++ is because I need the practice. So that's kind of why I'm here. But yeah, this works now in a very scuffed, awful way, and I really hate it. But yeah, it works. It does technically work. Okay, and it gets overwritten. We just have an extra move that we don't care about. Okay, so Let's commit. Do we print liveness still? Yes, we do. This is an interference, I believe. Wait, what? Uh-oh. Okay, let's delete that. Whoops. Let's actually not commit that one. Let's go play this playbook. Yeah, it's been a second. My internship has not started. I have half a year still, roughly. 4 months, actually. Man, this year's going fast. Man, I hate that. Okay. So let's make build so we don't run all the tests. I should start doing that. Then we run this. Everything is fine. Okay, cool. So then let's commit the stuff. What did we do here? Or insert missing nodes into interference graph. How do you get the internship? It was just like the company was at our career fair, so I showed up there. I talked with the guy. It turns out he knew he like told me that like in like college he like learned most of the system stuff except for like compiler stuff and networking stuff, and then like he did his master's and then he like got a lot of networking knowledge, but then like he never got a chance to learn about compilers. So like I chatted with him there just like at the stand for like 10 minutes. It was a good time. And then so like give them a resume, I like applied online, and then like the interview is like the interview, like OA is the OA. It wasn't really anything special, I feel like, but yeah. Starting compiler position soon myself, feeling massively unprepared. Well, congrats. I imagine like they don't expect everyone to be like completely like a compiler demon, so like I think you'll be fine at least. You might need to like do like a lot of learning, but that's kind of just life. Could you upload your Neovim setup? Yeah, it should be, all my dot files are they're on my GitHub. They should be pinned on my profile, which is in the description. Okay, so I think this means we've fixed this thing. I am like running out of time to fix printing though, so I will save this for next time. So this is liveness, or I don't know. I don't even print liveness anyway. It really does not matter. Once I like actually have to debug liveness, I think it will matter. But this means coloring is technically done, I believe, which is a very nice place to be. So all I need to do in terms of the road for like code gen is just like figure out how to spill and just like literally generate code. This includes like generating like preamble stuff. But that is everything. We're actually very close. And then from there, I think I will take some time to just like do some, what's it called? Do some benchmarking, compare it against Clang and GCC with and without opt. It'll be fun. It'll be a good time. Mentioned that I started my company. Ooh, 2 clients on board to get things started. Built an app which is live now. Grinding every day. Ooh. Well, good to hear that. Congrats on the work you've done. I imagine nothing will change insofar as like what you're working on, at least, or how much effort you're putting into it. But yeah, I'm gonna call the stream here. I do need to go. 7 is like my hard cap, and well, there is a clock there. Thank you all so much for showing up today. If you haven't already, make sure you like the stream and sub to the channel. It really does help out a lot with the algorithm, and given that I believe most of y'all showed up just from like the recommended page, keeping that up gets me, I guess, it helps a lot, given that's like my main audience source. While you're down there, make sure you like the stream. No, I just said that. While you're down there, check out check out the description. English is hard. I'm having a hard time. Check out the description. My Discord is there. Best place to get pinged when I go live because YouTube notifs suck. And also chat with everyone else in the community. Everyone is very chill. Also there is my GitHub and LinkedIn. I have not checked LinkedIn in an eternity, but feel free to add me on those to stay up to date with what I'm doing. And of course, my GitHub sponsors is there as well if you wish to support me financially. Yeah, take care y'all, take it easy, and have a wonderful rest of your day wherever you are.